All right, in Unit 2, we're going to be looking at systems. We will have two types of systems, systems of equations, which means we have two or more equations with two or more variables. Now we'll also be looking at systems of inequalities. Now, if you think about it, systems of inequalities would just be two or more inequalities with two or more variables. So it's really very similar. But what we're going to start with is the methods for solving systems, systems of equations, that is. So the methods for solving systems of equations. There are four main ones. Number one, we can graph it. Number two, we can use substitution. Number three, we can use what is called elimination. Your teacher may have called that combination. And the last one is matrices, and we will go into that later. Get this out of the way. So let's start with solving graphically. Solving graphically. It's pretty easy. Step one is to graph the equations. And two, we'll find the intersection. So let's look at an example of this. Actually going to take one from the warm-up. Get another color pen here. Let's say I have 8x plus 8y equals negative 16 and 2x minus 3y equals 9. Now we're going to solve these by graphing. So we will need to have a graph. Hope I'm giving myself enough room here. And we also will need to maybe rearrange these so they're easier to graph. Most people like to rearrange them into slope-intercept form to graph. So let's take equation 1 and solve for y, so it's in slope-intercept form. Got 8x plus 8y equals negative 16. Now I'm realizing off the bat here that, hey, everything is divisible by 8. If I divide both sides by 8, I might make this a little bit simpler. So if I divide this side by 8, 8x would become x, 8y would become y, and negative 16 would become negative 2. Now, to get y by itself, I need to get rid of the x. So to get rid of the x, you would subtract x on both sides. And I'll get y equals negative x minus 2. So let's go ahead and graph that. Has a y-intercept of negative 2. So -2, and the slope is -1, so that means I'm going to go down 1, right 1, down 1, right 1. And then I can connect my dots. Up 1, back 1, up 1, back 1. Yeah, there we go. Here is line 1. All right, line 2, let's use a different color. We've got 2x minus 3y equals -9. We want to get the term with the y by itself, so I need to get rid of the 2x. We do that by subtracting 2x from both sides. I'll get -3y equals -2x minus 9. Now we have a -3 times the y, so to undo multiplication, we divide both sides. By -3. So -3y divided by -3 is going to be y. -2 divided by -3 is going to be 2/3 x. And -9 divided by -3 is going to be a +3. So, y-intercept's at 3. Slope is 2/3. That's up 2 over 1, 2, 3. Or even down 2 and back 3. 1, 2, 3. Ooh! I see where they intersect. Oh, I see where I think they do. Now, if I had actually had graph paper, it would be a lot more easier. This looks like it's at, looks like -3, 1. So the intersection of that solution looks like it's at -3, 1. Now, I could also verify that. One way is to look at a table. So, I guess that's another way you can actually solve it. If I had a calculator, and I put both of those equations in, -x minus 2, oh, I have them in the wrong order, but that doesn't matter, and 2/3 x plus 3, and I looked at the table. You'll see the x values, and you'll see the corresponding y values for each of those lines. Let's see what happens when we get to the -3. If you look here, when x is -3, both equations have an output of 1. Both equations have an output of 1. It works. Now, there could be 3 options here, and I want to go ahead and bring this up. When you graph lines, you could get what we just got. Let me get 3 little pictures here. One option is that when you put 2 lines on a graph, that you end up with what we just had, which was the 2 lines intersecting. And they intersect at one spot, so it's one solution. And it is an XY. You are going to have a coordinate there. Now, the other option is that these 2 lines might never, ever, ever touch. And if you remember back from, that means they're parallel, right? When you have parallel lines that never, ever, ever touch, you will have no solution. They never touch. There is no way you could find an x value that works for both of them. It gives you the same y value output because they never touch. Now, the last option is maybe I graph this line, rearrange the other one, and graph it, and it ends up coming right on top. So we end up with the same line. Here we had parallel lines. here, I've got the same line. That means that every point on this one is exactly the same as every point on this one. This would mean that we have not one solution. We have thousands, millions, infinite solutions. Now, let's take a look at solving algebraically. So let's go over the steps for that. Solving algebraically. And actually, as I go through this, I'm going to use an example to walk you through it. So this is number 2. Solving algebraically. Solving by substitution is really what we want to go with this, substitution. And the easiest way to really go through this is to actually go through an example or two. So 3x plus 2y equals 1. And I've got negative 2x plus y equals 4. So I've got my two equations with two variables. What I want to do is take one of those equations, either equation number 1 or equation number 2, and I want to solve one of those equations for one of the variables. I want to get one of the variables by itself. So if we look closely at these two equations, there's one that's going to be easier to rearrange than the other one. And that's usually how you can tell that substitution is a great thing, especially when you see a variable like this that has no coefficient. I am thinking that this is a great substitution problem. I'm going to take equation 2 and solve for y. When I do that, let's see what happens. So I have negative 2x plus y equals 4. Add 2x to both sides. When I add 2x over here, it goes away. Add 2x over here, I get positive 2x plus 4. Now, substitution. The key is we have found an equivalence for y. What this is telling me is that y is equal to this expression. It's almost as if somebody had told you what y's value actually was. If somebody had told you that y was 10, you know, you can just plug in 10. Same idea here. This is telling me that y can be rewritten as 2x plus 4. Whoops. Hold on. Sorry for that interruption. All right. I'm going to take equation 1 and take this expression we found by rearranging equation 2 and substitute that in for y. I'm going to replace y with what it's equal to, because that's always allowed. When I do that, I'll still have the 3x and the plus 2, but instead of writing y, I'm going to write what it's equivalent to, which is the 2x plus 4. Now, you'll notice that we don't have any y's anymore. We just have x's. That we can solve. We distribute, combine like terms, subtract 8 from both sides, and then divide by the coefficient of x. So I now have x. Now remember, we're trying to find that point of intersection, that point where both equations have the same y value for their x. So I need to find that y value as well. So here I already have an expression for y in terms of x, so why not just plug that x right in there? I'd get y equals 2 times negative 1 plus 4. Pretty nifty. Let's do another example here for substitution. x minus y equals 4, and negative 6x plus 6y equals 18. All right. So I'm looking for which equation to solve for one of the variables. So let's see. How about let's take equation 1 again. Doesn't matter which one we pick. I'm going to solve equation 1 this time for, how about x? Looks like that would be a pretty easy one to do. So here's equation 1, x minus y equals 4. If I want to solve for x, that means I'm getting x by itself, so I need to add y to the other side. And I get x equals y plus 4. So, remember, we rearranged 1 this time, so we need to substitute into equation 2. So what I'm going to do is take this expression, and since that's what x is equivalent to, this is going to replace x. Everything else stays the same. Negative 6 is still there. 6y is still there. The 18 is still there. They don't go anywhere. I'm just replacing the x with what it's equal to. So negative 6 times y is going to give me negative 6y. Negative 6 times 4 is going to give me a negative 24. Plus 6y equals 18. Combine like terms. Uh-oh. My variable disappeared. Now, when the variable disappears, we have two options. We are left with a true or false statement. If I have a true statement, what that means is no matter what value I plug in for y, I'll always get a true statement out. False statement, I'm saying whatever I plug in, I'll always get a false statement out. Because if it's true, that means it's always true no matter what value you plug in for your variable. If it's always true, that means it doesn't matter what I plug in, so any number will work. That's infinite solutions. Now, what would that mean graphically? That would mean that we'd have the same line. Now, if we get a false statement like we did here, what that tells me is that I'm never going to get a solution. It's never going to work. So I'd have no solution, which would mean we'd have parallel lines. Okay, the next method is elimination. Now, the point of elimination is we want to add the equations together so that one variable is eliminated. We want to make sure one variable gets eliminated. Now, I'm going to go ahead and do a little step-by-step process, but as I do it, I'll do an example as we go along. What we're going to do is look at the equations and multiply one or both equations by something that will give us opposite coefficients. And when I say opposite coefficients, we're talking about one's got to be positive and one's got to be negative, but the same number. So for my example here, I'm going to use 8x plus 2y equals 4. And this one's going to be negative 2x plus 3y equals 13. We want to somehow get one of the variables to be eliminated by having opposite coefficients. If you'll notice, we already have one that's positive and one that's negative, so we're halfway there. So x might be a good target. So I'm going to write down that I'm going to plan on eliminating x. Now, what could I do to eliminate x? Well, how about let's just leave the first one just like it is. I'm going to rewrite it over here. But on the second one, to make it be an opposite of 8x, I need this to be negative 8. What could I multiply by to get that to be negative 8? I can multiply by a 4. So times 4. And when I say times 4, we're talking about both sides of the equation. So that gives me negative 8x plus 4 times 3y is 12y. And then 4 times 13 is going to be 52. Now, we did that so that we could add the equations together. So that's the next step. Add the equations. Now, if we did it right, we're going to eliminate x. It's going to be gone, out of there, nowhere to be seen. See if it works. So we're going to add these two equations together. 8x plus negative 8x. It is gone. 2y plus 12y gives me 14y. 4 plus 52 is going to give me a 56. Wow, that is a simple equation to solve. Just divide by 14 and we get y equals 4. Halfway there then. I know what y is. I need to substitute back into either equation so that I can find the other variable. Now either one will work. Let's just go with the first one. The first one has 8x plus 2y equals 4. Plugging in 4 for y, that's 8x plus 2 times 4 equals 4. 8x plus 8 equals 4. Subtract 8 from both sides, I get 8x equals negative 4. So x equals negative 1/2. That means my solution is negative 1/2, comma 4. Let me do one more example here. Next example, 2x plus 3y equals negative 7. 4x minus 5y equals 19. Okay, so we need to figure out which variable we want to eliminate. Do we want to eliminate the y or the x? Either one is going to take a little bit of work. I'm leaning toward the x's on this one. So my plan is to eliminate x. Now to do that, since this one's a 4x, I need to multiply by this one in a way that would give me a negative 4x. So I'm going to multiply by negative 2. I get negative 4x, then that'd be a negative 6y. Negative 2 times negative 7 is going to give me a 14. And we add these two together. Good, they did eliminate. I get negative 11y equals 33. Divide by negative 11. I get y equals negative 3. Wow, we're almost there. That just needs to plug back into either one of the equations to find x. Doesn't matter which one you pick. I'm going to go with the first one just because it's the first one. I'm going to take that value and plug it in for y. So 2x plus 3 times negative 3 equals negative 7. 2x minus 9 equals negative 7. Add 9 to both sides. I get 2x equals 2. X equals 1. My solution will be 1, negative 3.